The Atacama Desert occupies a long, narrow band along the Pacific edge of northern Chile. It is defined by dryness rather than heat. Rainfall is rare enough that exposed ground can remain unchanged for decades. The surface appears static, but beneath it lies a complex structure of fractured rock, mineral veins, and excavated corridors that extend deep below the desert floor. Near the city of Copiapó, mining has altered this subsurface for more than a century. Copper and gold deposits run through hard volcanic and sedimentary layers. To reach them, operators carved inclined ramps and vertical shafts that descend several hundred meters. These passages are reinforced in places, bare in others, and shaped by practical necessity rather than symmetry. Air is circulated mechanically. Light exists only where power is supplied. At a depth of approximately 700 meters, conditions differ sharply from those at the surface. Temperatures rise steadily with depth. Natural airflow is limited. Sound carries unevenly, absorbed by rock in some sections and amplified in others. Time is measured by work cycles rather than daylight. For those who labor there, the underground is not a place of threat but of routine. The San José Mine was one of several active operations in this region. It lay about 45 kilometers northwest of Copiapó, set back from major roads, surrounded by low hills of pale stone. From above, it presented little sign of its scale. A small cluster of buildings marked the entrance. Conveyor belts, electrical lines, and access roads connected the surface to what lay below. Before August 2010, the mine functioned as it had for years. Crews descended at the start of shifts, carried out drilling, blasting, and hauling, and returned to the surface when their assigned hours ended. The refuge chambers, mandated by regulation, were stocked but rarely used. They existed as contingencies, not destinations. The underground environment did not announce danger. Rock walls showed the usual scars of extraction. Equipment noise blended into a constant mechanical presence. The deeper levels were familiar to those assigned there. On the morning of August 5, the mine was operating within expected parameters. The desert above remained still. Below it, work continued as planned. No event had yet occurred to distinguish that day from others that came before it. The San José Mine was situated in the mineral-rich foothills of the Atacama Desert, approximately 45 kilometers northwest of Copiapó. It operated as a medium-scale copper and gold mine, drawing from ore bodies embedded in fractured volcanic rock. Mining activity at the site dated back several decades, with periods of inactivity followed by reopening under new ownership and revised extraction plans. By 2010, the mine was privately owned and operated by Compañía Minera San Esteban Primera. Its methods were conventional for the region. Ore was accessed through a spiral ramp that descended gradually into the mountain, allowing trucks and machinery to move between levels. Additional shafts and crosscuts branched outward from the main access route, creating a layered network of tunnels. The mine reached depths of more than 700 meters. At those levels, structural integrity depended on a combination of natural rock stability and artificial reinforcement. Some sections were supported with steel mesh and rock bolts. Others relied on the inherent strength of the surrounding stone. This uneven reinforcement reflected both the mine's long operational history and financial constraints faced by its operators. Safety at San José had been a documented concern prior to 2010. Chilean regulatory records show that the mine had been cited multiple times for safety violations, including inadequate ventilation and unstable rock conditions. In 2007, a fatal accident occurred when a miner died after a rockfall. The mine was temporarily closed and later allowed to reopen following reported improvements. These measures, however, did not eliminate underlying geological risks. Inspections were conducted by the National Geology and Mining Service of Chile. While the mine remained legally operational, concerns persisted regarding its emergency preparedness. Refuge chambers were installed as required by law. These chambers were designed to provide temporary shelter in the event of collapse, stocked with limited food, water, and oxygen supplies. Their intended purpose was short-term survival until contact with the surface could be restored. Daily operations followed established routines. Crews were assigned to specific levels and tasks, including drilling blast holes, loading explosives, reinforcing tunnel walls, and transporting ore to the surface. Shifts were long and physically demanding. The work required familiarity with heavy equipment and an understanding of how rock behaved under stress. The mine's remoteness added another layer of complexity. Access roads were limited. Communication infrastructure was functional but basic. In the event of a serious incident, outside assistance would require time to arrive. These factors were understood by regulators and workers alike, though they were often treated as acceptable risks within the context of regional mining practices. Despite its record, the San José Mine remained in operation because it provided employment in an area where mining was a primary economic activity. Many workers had few alternatives. Experience, rather than formal assurance, shaped their assessment of danger. The underground environment was familiar, and familiarity often reduced the perception of risk. On August 5, 2010, the mine was active at depth. Work was underway in several sections. Equipment was in use. No evacuation order had been issued. The infrastructure functioned as it had on previous days. The conditions that existed, geological, structural, and administrative, were the result of years of accumulated decisions. The mine did not fail because it was abandoned or unknown. It failed while in use, under observation, and within a system that had accepted its limitations. The group later identified as the 33 consisted of men assigned to work the deeper levels of the San José Mine. They ranged in age from early 20s to late 50s. Some had spent most of their working lives underground. Others had joined the mining workforce more recently, drawn by the promise of steady wages in a region where employment options were limited. Their roles varied. Among them were drill operators, mechanics, truck drivers, electricians, and supervisors. Each position carried specific responsibilities that were understood through practice rather than written instruction. Skill was acquired over time, often passed from older workers to younger ones. Formal training existed, but much of the knowledge required to operate safely at depth was informal and situational. Several members of the group had worked at San José for years. They were familiar with its layout, its patterns of sound, and the locations where rock was known to be unstable. Others had experience in different mines across northern Chile. Movement between sites was common in the industry, and workers brought habits and expectations shaped by previous assignments. On August 5, 2010, the men descended as part of a routine shift. Their tasks included drilling and/or extraction near the active production phase. This area was located hundreds of meters below the surface, accessible only by the main ramp. The work zone was not unusual in its configuration. Equipment had been positioned. Ventilation was operating. No immediate hazards had been reported at the start of the shift. The group was not assembled deliberately. They were present because their assigned duties overlapped in time and location. Some were nearing the end of their shift. Others had several hours remaining. Movement between sections occurred as tasks required, but all remained within the lower levels of the mine. Experience influenced how each man understood risk. Minor rockfalls were common in underground mining and were generally treated as manageable events. The mine had endured previous incidents without catastrophic outcomes. This history shaped expectations. The possibility of a complete blockage of the access ramp was considered remote. Personal circumstances differed, though these details were not relevant to the work itself. The mine did not record family status, financial obligations, or future plans as part of operational data. What mattered underground was physical presence, technical ability, and adherence to routine. The men carried standard safety equipment, helmets, lamps, protective clothing. They relied on powered machinery and the mine's infrastructure for light, air, and movement. Communication with the surface was indirect, routed through established systems rather than continuous contact. At the moment before the collapse, the group functioned as a workforce rather than a collective unit. There was no shared anticipation of crisis. Each individual was engaged in his assigned role, within a system that had operated in similar fashion on many prior occasions. What united them was not preparation for survival, but coincidence of location. Their proximity in the lower levels would later determine who was trapped and who escaped. Those working closer to the surface were able to withdraw. Those deeper inside were not. The number 33 had no significance at the time. It was not counted or remarked upon. It would only gain meaning after contact with the surface was lost. The rockfall occurred on August 5, 2010, during the afternoon hours. Its precise initiation point was within the upper sections of the mine, along the main access ramp that connected the deeper levels to the surface. This ramp was the primary route for vehicles, personnel, and ventilation. Its integrity was critical to all operations below. Geological conditions in the area included fractured rock and fault lines that had developed over long periods. Stress accumulated as material was removed from surrounding sections. When failure occurred, it did not take the form of a single, clean break. Instead, a large mass of rock detached and collapsed into the ramp, followed by additional material shifting into the newly opened space. The immediate effect was the obstruction of the main access route. Dust and debris traveled downward through connected tunnels. Air movement was disrupted. Electrical systems in some sections failed temporarily. Those working at depth became aware of the event through sound and vibration rather than sight. Attempts were made to assess the situation from below. Equipment could not pass the blockage. The ramp was filled with rock and debris over a length of several meters. The volume involved exceeded what could be cleared with the tools available underground. The collapse also damaged auxiliary escape routes, either directly or through secondary rock movement. Communication with the surface ceased. Fixed-line systems were disabled by the collapse. Radio signals could not pass through the intervening rock. The men below had no means of determining the extent of the damage above them. They could not know whether the surface facilities were intact or whether the collapse had been detected. At this point, isolation became unavoidable. The depth at which the group was located prevented ascent by any alternate path. The mine's design did not include redundant access routes capable of bypassing the affected area. What had functioned as a workplace became a closed environment. The decision to move toward the emergency refuge was made in accordance with established safety protocols. The refuge chamber was located at a known distance from the work area and was intended to provide shelter in the event of collapse. It was not designed for long-term habitation, but it offered the only environment with secured air and limited supplies. Movement through the tunnels was slowed by debris and poor visibility. Headlamps provided narrow fields of light. The air was heavy with dust. The group gathered as they proceeded, accounting for those present. No fatalities occurred at the moment of collapse among the 33. This outcome was the result of timing and location rather than design. Once inside the refuge chamber, the men assessed their situation based on what they could observe. The access ramp was blocked. Communication was absent. The duration of isolation was unknown. The chamber door was closed to stabilize the environment inside. The point of no return had been reached without ceremony. There was no moment of announcement. The transition from labor to survival occurred through circumstance, governed by physical barriers rather than choice. The emergency refuge chamber was a reinforced room carved into the rock near one of the lower levels of the San José Mine. Its location was known to those who worked at depth, though few had ever entered it except during inspections or drills. It was designed to withstand localized collapse and to provide a temporary sealed environment if escape routes were cut off. The chamber measured only a few meters across. Its walls were lined with steel panels anchored into the surrounding stone. A heavy door could be secured from the inside. Ventilation was passive rather than active, relying on the limited exchange of air through connected shafts until those passages were blocked or compromised. Lighting was minimal and dependent on stored power. Inside the refuge were emergency supplies. These included small quantities of canned food, crackers, powdered milk, and water stored in plastic containers. The provisions were calculated to sustain a limited number of people for a short duration, under the assumption that rescue or re-establishment of access would occur within days. The presence of 33 men exceeded the design capacity of the space. Initial actions focused on accounting for resources. Food and water were counted and divided. Rationing was implemented immediately. Each man received a small portion per day, measured carefully to extend the available supplies. Consumption was reduced to the minimum required to maintain physical function. This practice is documented in post-rescue accounts and medical evaluations. Water management was critical. The stored water was supplemented by moisture collected from the mine environment. Condensation formed on tunnel walls due to temperature differences between rock and air. This moisture was gathered using cloth and containers where possible. The quantities obtained were small but contributed to survival. Leadership emerged through practical necessity rather than formal designation. One of the miners, who had prior experience coordinating crews, assumed responsibility for organizing routines and enforcing rationing. Decisions were discussed among the group, but adherence to structure was maintained to prevent disorder. This arrangement is consistently reported in survivor testimonies. Daily routines were established to impose order on an otherwise unstructured environment. Sleep periods were assigned. Tasks such as cleaning the chamber, managing waste, and monitoring health were rotated. Time was tracked using improvised methods, including counting meals and rest cycles. Without natural light, maintaining a sense of day and night required deliberate effort. The physical environment imposed continuous strain. Temperatures in the refuge rose above 30 degrees Celsius. Humidity increased as bodies and limited airflow added moisture to the air. Sweat did not evaporate easily. Clothing remained damp. These conditions contributed to fatigue and skin infections, which were later documented by medical teams. Sanitation posed a significant challenge. No toilet facilities existed within the chamber. Waste was managed using containers and isolated areas of the tunnel system, as far from the living space as possible. Efforts were made to minimize contamination and odor, but complete separation was impossible. Hygiene practices were limited by water scarcity. Medical issues arose gradually. Minor injuries from the collapse required attention without proper equipment. Pre-existing conditions, such as diabetes and respiratory problems, had to be managed with limited medication. Food rationing affected blood sugar levels and overall strength. Weight loss occurred steadily among all members of the group. Psychological pressure was present but managed through routine and mutual observation. Confined space, darkness, and uncertainty exerted continuous influence. According to documented accounts, overt panic was limited. This has been attributed to the structured environment and the shared understanding that cooperation was essential. Efforts were made to establish contact with the surface. The men listened for sounds of drilling or movement. At intervals, they attempted to reach areas where communication equipment might still function, though these efforts were constrained by the blockage. For many days, no confirmation of outside awareness was available. After approximately 17 days, a drilling probe from the surface reached the refuge area. This event is fully documented. The men attached a note to the drill bit, written on paper available within the chamber. The message confirmed that all 33 were alive. This moment marked the end of complete isolation, though rescue was still distant. From that point forward, the nature of survival changed. Supplies were lowered through the drill hole, including food, water, medical materials, and communication devices. The men followed instructions from surface teams, including dietary adjustments and medical monitoring. Exercise routines were introduced to maintain muscle function. Where detailed records exist, they describe measured adaptation rather than improvisation. Where records are incomplete, historical reconstruction suggests that daily life remained focused on maintaining order, conserving energy, and responding to external guidance. No contradictory evidence has been presented. The refuge chamber was not intended for long-term habitation. Its limitations were evident. Yet within those constraints, the men sustained themselves for 69 days. This outcome resulted from rationing, cooperation, and the gradual extension of support from above. As days extended into weeks, the physical condition of the men changed in measurable ways. Medical records compiled after their rescue indicate significant weight loss among all 33. Average losses ranged from several kilograms to more than 10, depending on individual metabolism and pre-existing health conditions. Muscle mass decreased as caloric intake remained low and movement was restricted. The environment within the lower levels of the mine continued to deteriorate. Heat increased steadily. Temperatures exceeded 32 degrees Celsius in some sections. Ventilation remained limited despite efforts from the surface to improve airflow through drilled shafts. Humidity remained high, contributing to dehydration and discomfort. These conditions were not uniform, varying slightly depending on proximity to air circulation points. Psychological strain was present throughout this period. Uncertainty regarding the timeline of rescue persisted even after contact was established. Drilling operations on the surface were complex and subject to delays caused by equipment failure and geological instability. Several early drilling attempts failed to reach the refuge chamber or were abandoned due to deviation or collapse. These failures were communicated to the men underground in controlled terms, according to official accounts. The awareness of risk increased as the duration of entrapment became clear. The mine remained unstable. Secondary collapses occurred in upper sections, though none directly impacted the refuge chamber. Each reported event reinforced the understanding that rescue was not guaranteed. Health management became more structured after surface teams provided guidance. Medical personnel monitored vital signs through reports sent via communication lines. Diets were adjusted to reintroduce calories gradually, in order to prevent metabolic shock. The men followed prescribed routines with limited deviation. This discipline was documented by both Chilean authorities and international observers. Sleep patterns remained irregular. Artificial lighting was rationed to conserve power. Noise from drilling operations above was intermittent, sometimes audible, sometimes absent for long periods. The absence of sound was often more difficult to interpret than its presence, as it provided no information about progress. No deaths occurred during this phase. This outcome contrasts with many historical mining entrapments and is supported by complete medical and operational records. However, the risk of serious illness increased as time passed. Fungal infections, dental problems, and gastrointestinal issues were reported after rescue and attributed to prolonged confinement. The men were aware that multiple rescue strategies were being pursued simultaneously. These included drilling larger diameter shafts capable of extracting individuals one at a time. The technical challenges of maintaining alignment over hundreds of meters of rock were significant. Progress was measured in centimeters per hour. During this period, the distinction between survival and rescue blurred. The men were no longer entirely self-sufficient, yet they remained physically confined. Their role shifted toward endurance and compliance with externally imposed routines. The decline was gradual rather than sudden. Strength diminished, but cohesion remained. The environment continued to exert pressure, but it did not overwhelm the systems that had been established. Survival persisted as a managed condition, sustained by structure, information, and time. Once sustained communication had been established, rescue planning moved from uncertainty to coordination. 3 separate drilling strategies were initiated from the surface, identified as Plans A, B, and C. Each involved different equipment and trajectories intended to reach the refuge chamber or an adjacent tunnel. This redundancy reflected both the depth involved and the instability of the surrounding rock. Plan B proved successful. A drilling rig capable of creating a shaft wide enough to extract a single person was positioned above the mine. Progress was slow and monitored continuously. Engineers adjusted alignment to account for rock hardness and deviation. The men underground received regular updates through written messages and audio contact, which allowed them to prepare for extraction procedures. As the shaft neared completion, a steel rescue capsule was lowered for testing. The capsule, later named Phoenix, was designed to fit tightly within the drilled shaft. It included harness points, oxygen supply, and communication lines. Its dimensions allowed only one occupant at a time, standing upright. Medical teams determined the order of extraction. Priority was given to those whose health required earlier attention, as well as individuals whose skills were needed on the surface to assist in coordinating subsequent rescues. This sequence was documented and followed without deviation. The first extraction occurred on October 13, 2010. Each ascent took approximately 15 minutes. The capsule was raised slowly to minimize risk of mechanical failure or physiological stress. Upon reaching the surface, each man underwent immediate medical evaluation before being transferred for further observation. The process continued over the course of approximately 24 hours. All 33 men were brought to the surface alive. No fatalities occurred during extraction. This outcome was confirmed by Chilean authorities and observed by international media and rescue specialists. The mine remained closed during and after the operation. Investigations into the cause of the collapse and the mine's safety practices followed. These inquiries produced detailed reports and recommendations, some of which informed subsequent regulatory changes. The extraction marked the end of physical confinement but not the end of medical or administrative processes. The men were hospitalized briefly, then released under continued monitoring. Long-term health effects varied, though no immediate life-threatening conditions were reported at the time of rescue. The rescue was conducted without haste. Each stage was deliberate, measured, and recorded. The operation concluded as planned, with all individuals accounted for. The period of confinement lasted 69 days, from August 5 to October 13, 2010. This duration is confirmed by operational records and medical documentation. Throughout that time, 33 men remained underground at a depth of approximately 700 meters. Their survival without loss of life is fully documented and remains uncommon in the history of mining accidents. The San José Mine did not reopen. Its closure followed investigations that examined geological conditions, operational decisions, and regulatory oversight. Reports identified structural instability and deficiencies in safety management. These findings contributed to renewed scrutiny of mining practices in Chile and beyond. The event altered established assumptions about the limits of survival underground. It demonstrated that extended confinement could be endured under certain conditions, given access to basic resources, disciplined organization, and sustained external support. It also highlighted the consequences of operating in environments where known risks are managed rather than resolved. From a historical perspective, the incident occupies a distinct place. It was not the deepest entrapment, nor the longest by duration, but it was among the most thoroughly observed and recorded. The presence of complete survival data, medical records, and engineering documentation distinguishes it from earlier cases. The men returned to the surface individually, but the event is remembered collectively. Their experience does not suggest heroism or exception. It reflects the outcome of accumulated decisions, environmental factors, and technical intervention. The mine remains part of the Atacama landscape, altered by excavation and closure. Above it, the desert continues unchanged. Below, the tunnels persist in darkness. The 69 days passed without reversal, leaving a record of endurance defined not by narrative, but by fact.